All right, let's dive right into this explainer. We're looking at the ultimate exam cheat sheet today, something that's going to turn hours of tedious, mind-numbing math calculations into rapid-fire solutions. If you've ever felt completely bogged down by squares and square roots, get ready because we are about to completely upgrade your mathematical toolkit.
So here's the game plan. We're unlocking 6 massive cheat codes today. Spotting perfect squares, odd, even, and sums, Pythagorean triplets, quick calculation hacks, finding square roots, and finally, real-world math. Jumping right into Section 1, spotting perfect squares, sight reading the fake numbers. Picture this. You're sitting in an exam, the clock is ticking down, and bam, you see a massive number like 5,963 on your test. The question asks if it's a perfect square. Now, are you going to waste precious time trying to find its square root with long division or prime factorization? No way, absolutely not. Instead, you just look out for these 4 red flag digits. If you glance at the units place, that very last digit on the right of any number, and you see a 2, a 3, a 7, or an 8, stop right there. It is literally mathematically impossible for that number to be a perfect square. So, since 5,963 ends in a 3, you can instantly declare it a fake and breeze right on to the next question. And here's another awesome visual shortcut, the zeros rule. Just look at the zeros at the very end of the number. If there's an odd number of trailing zeros, like, say, the 3 zeros and 64,000, that guarantees it's a fake. No calculations needed. But if it has an even number of trailing zeros, like the 2 zeros and 6,400, well, then it actually could be a real perfect square. Moving on to Section 2, odd, even, and sums, recognizing mathematical patterns. All right, burn this ironclad rule into your memory. Even numbers only ever produce even squares, and odd numbers only ever produce odd squares. So if a test asks you whether the square root of 441 came from an even or an odd number, you literally just look at the last digit. It ends in a 1, which is odd, so its square root absolutely has to be an odd number. Simple as that. Now, this is where it gets really fun. If an exam asks you to add up a super long string of consecutive odd numbers starting from 1, please, whatever you do, don't add them up manually. Just count how many numbers are in the sequence and square that total count. Like in our example, there are 10 consecutive odd numbers, right? Well, 10 squared is 100. Boom, you've got your answer in like 5 seconds, 0 addition required. Okay, let's jump to Section 3, Pythagorean triplets, finding the missing family members. You know those triplet families? To find them, you really don't need to guess and check numbers until they magically fit into a squared plus b squared equals c squared. You just need to memorize these 3 little algebraic family members, 2m, m squared minus 1, and m squared plus 1. Honestly, these 3 formulas are basically the keys to unlocking any triplet question. Let's actually see this in action. Say your exam gives you a smallest member, like the number 6, and asks for the full triplet. You just set 2m equal to 6, solve for m, which gives you 3. Then you just plug that 3 right into the other 2 formulas. 3 squared minus 1 is 8, 3 squared plus 1 is 10, and just like that, you've instantly revealed the whole family, 6, 8, and 10. Next up, Section 4, quick calculation hacks, bypassing the long arithmetic. Okay, you're going to want to keep this algebraic identity in your back pocket. The difference of 2 squares, a squared minus b squared, is exactly equal to a plus b multiplied by a minus b. This little formula is a total game changer because it lets you solve the difference between 2 squares without ever actually having to calculate those massive squares themselves. Check out how crazy this is. When examiners give you consecutive numbers to square and subtract, like 38 squared minus 37 squared, the a minus b part of our formula just becomes 1. Which means you can literally just drop it. For consecutive numbers, you just add the 2 base numbers together to get your final answer. 38 plus 37 is 75. No multiplying massive, clunky numbers, just simple everyday addition. Moving right along to Section 5, finding square roots, the prime factorization method. So, finding a square root through prime factorization, it's essentially just a mathematical matchmaking game. First, you break the number down into its lowest prime factors. Then, you group the identical numbers into couples. After that, pull exactly one number from each couple and multiply them together. For 225, your couples are a pair of 3s and a pair of 5s. Pull out one 3 and one 5, multiply them, and you get 15. Easy, right? But wait, what happens when the matchmaking fails? If you have a number like 252 and it's got this lone 7 just sitting there without a pair, it means the number is not a perfect square. But exams love to ask you how to fix it. Well, you've got two choices. Either multiply the whole thing by 7 to give it a partner, or divide the whole thing by 7 to just kick that lone number out completely. Either method forces that messy number into becoming a perfect square. Real quick, let's take a slight detour to bust some math myths that examiners absolutely love using to trick you on true or false sections. First myth, the square of a prime number is always prime. False, just look at 2 squared, which is 4. Second myth, the sum of 2 perfect squares is a perfect square. Again, false. 4 plus 9 equals 13, definitely not a square. But the product, if you multiply 2 perfect squares together, the result is always a perfect square. Don't let them trick you on those.
And finally, Section 6, Real-World Math, Escaping the Garden Maze. When you first read a word problem like this on an exam, honestly, it sounds like an unsolvable riddle. You've got this massive number of plants, 1,225, and this weird clue that the number of rows exactly equals the number of plants per row. Like, where do you even begin with that?
Well, the riddle completely collapses once you write it out algebraically. If the number of rows is x and the plants per row is also x, then x times x equals your total. All of a sudden, you realize it's not a riddle at all. It's literally just a disguised square root question. We just need to find the square root of 1,225.
And hey, we know exactly how to do that. You just break out your prime factorization matchmaking tools on 1,225, find your prime factors, pull out the matching pairs of 5s and 7s, multiply them together, and boom, you have exactly 35 rows. You've completely beaten the tricky word problem using just basic, fundamental logic. So you're now fully equipped to completely dominate your exam, using these structured hacks, saving yourself tons of time and mental energy on whole numbers. But tell me this, how would you approach finding the square root of a completely messy decimal point? That requires a totally different strategy, and it's definitely something worth thinking about as you continue to level up your math skills.